Today we're going to talk about another method of solving systems of equations. This method is called the substitution method. Let's think for a minute what the word substitution really means. If you think about a substitute in a classroom, that is a person who replaces the teacher for the designated period of time. By definition, the substitution method is a method of solving systems of equations by substituting equations within one another. Keep in mind, a system must have at least two equations, so you're going to be able to substitute pieces or parts into one equation from the other. Here are your steps. Step 1. You need to first solve one equation for either x or for y. I suggest you choose whichever would be easier. Step 2. Substitute this expression into the other equation and solve for the variable. Step 3. Substitute your answer into the revised equation from step 1 and solve for the other variable. Keep in mind, the solution to a system of equations is an ordered pair. Occasionally, there will be no solution, and occasionally, it will be infinitely many solutions. Let's take a look at some examples. Example number 1, y equals 4x minus 1 and y equals 2x minus 5. Notice both of these equations are solved for x. For that very reason, we can set them equal to each other by substituting out the y for 2x minus 5. Now we will go ahead and solve this equation. Notice I'm getting my variables to the left. Then I will get my constants to the right. Divide by the coefficient. And I come up with x equals -2. I will now take -2 and plug it back into one of your original equations. It does not matter which one you plug back into. I'm going to choose to plug into this bottom equation. So that would be y equals 2 times -2 minus 5, which would be y equals -4 minus 5, therefore y equals -9. To write the solution to this system, you're going to write your x value of -2 and your y value of -9. Alright, let's take a look at another example. For this example, you already have one equation where a variable is solved for. Notice the y is all by itself. So what I'm going to do is I'm going to take the y out of that second equation and replace it with 6x. So I will keep 2x, I will keep the plus, keep the 3, take out the y and replace it with 6x, keep the equals, and keep the -20. Now that you only have one variable in your equation, you can then solve for its value. So you have 2x plus 18x equals -20. Therefore, 20x equals -20. Divide both sides by 20 to give you x equals -1. You will then take -1 and plug it back into either one of these equations. I always suggest that you choose the equation that looks simpler to plug into. I'm going to choose to plug into this first equation. So, in the place of x, I'm going to put the -1. So I come up with y equals -6. Therefore, my solution is -1, -6. Our next example is x plus 5y equals 4, and 3x plus 15y equals negative 1. And this is actually number 7 from the worksheet. And the previous one was number 2. Okay, so for number 7, notice neither one of these equations has a variable that's by itself. If I look at this first equation, however, it's going to be pretty easy to get x by itself, because the only thing that you need to move is the 5y. So what I'm going to do is I'm going to move 5y to the other side of the equation, and that's going to give me x equals negative 5y plus 4. When you move a positive term to the other side of the equal sign, it becomes a negative. Okay? Since I now have an x all by itself, I'm going to take the x out of the second equation and replace it with negative 5y plus 4. It's going to look like this. Keep the 3, take out the x and replace it with negative 5y plus 4. Keep the plus 15y, keep the equals negative 1. You will now distribute, which will give you negative 15y plus 12 plus 15y equals negative 1. Combine like terms, negative 15y and 15y will actually add together and they will cancel out. So you're left with 12 equals negative 1. We've seen this kind of answer before when solving an equation, so it can apply as well in a system of equations. We all know that 12 will never equal negative 1. Therefore, this is no solution. Meaning, what's the answer to this system? No solution. And if that's true, what do you know about your lines? Well, if there's no solution, that means you have a set of parallel lines. Because as you saw with the graphing method, any system that had no solution indicated that it was a set of parallel lines because they never intersect. Alright, let's look at example number 8. You have x plus 4y equals 0, and 3x plus 2y equals 20. Again, you need to solve one of these equations for a variable. I would suggest that you solve the first equation for x, because the way you would solve for it is by simply moving the 4y to the other side of the equation. If you were to solve for the x in the second equation, you would not only have to move the 2y, but you would also have to move the 3. You always want to look for whichever equation has a simpler process to get a variable by itself. Okay, so to get x by itself, we're going to subtract the 4y to the other side, which will give you x equals negative 4y plus 0. Okay, let's keep in mind though that the plus 0 doesn't change its value, so you don't really need to put it, but you can if you so choose. I'm going to go ahead and get rid of it because plus 0 doesn't change anything, so it is not a necessary component. Now that I have x by itself, I'm going to look at my second equation and take the x out of it. I'm then going to replace that x with what x equals, which is negative 4y. So for this second equation, you're going to keep the 3, take out the x and replace it with negative 4y, keep the plus 2y, and the equals 20. 3 times negative 4y will give you negative 12y. Bring down the plus 2y equals 20. Combine your like terms to give you negative 10y equals 20. Divide both sides by the coefficient to give you y equals negative 2. Now that you have a value for one of your variables, you're going to take that value and plug it back into one of your original equations. You could, if you would prefer, plug it into this equation here. So I'm going to take negative 2 and plug it in to this equation right there. So that's going to be x equals -4 times -2. That's going to give you an x value of +8. Therefore, your solution to this system would be the ordered pair 8, -2. Let's take a look at one additional example. This is number 9 from the worksheet. You have 6x plus 3y equals 54, and you have 2x plus y equals 18. For this system, I would suggest that you try and get this y right here to be by itself. It is only going to require you to move the 2x to the other side of the equation. However, you could, if you wanted to, solve this first equation for x by moving the 3y and dividing everything by 6. You could, if you would like, to get the x by itself, you could subtract the 3y from both sides and divide everything by 6. If you wanted to get y by itself, you would have to subtract 6x and divide everything by 3. If you wanted to get this x by itself, you would have to subtract the y and divide everything by 2. Like I said, I'm always going to suggest to you the easiest and shortest process. So I'm going to suggest that you get this y right here to be all by itself, because it's only going to require you to move the 2x to the right side. So, when you rewrite this equation, you're going to have y equals -2x plus 18. Now that you have y by itself, you can take the y out of the first equation and replace it with -2x plus 18. Here's what that will look like. Keep the 6x, keep the plus, keep the 3. Take the y out and replace it with -2x plus 18. Keep the equals and the 54. Then you are going to distribute your 3. Then you're going to combine your like terms. Notice your x's are going to cancel out because they're opposites. So you're left with 54 equals 54. Again, we've seen answers like this when solving equations. We know that 54 will always equal 54. Therefore, this solution is infinitely many solutions. What does that mean in terms of visually on a graph? That means that you have two identical equations. Okay? Graphically, they lie right on top of each other. That's kind of hard to see when you look at it like this. But I will tell you that both of these equations are equivalent to each other. I will show you how to determine that when we learn our next method of solving a system of equations.